Hi, I'm Alan Ross, and I am the Technical Director of Transformer Technology, Power Systems Technology, and Women in Power Systems. So I am delighted today to have as a guest that I've had before previously, Senja Leivo from Vaisala. She is a brilliant leader of the technical and the development part of Vaisala. So welcome. Thank you for being here.
Hi, Alan, and thank you for having me here.
So we're going to talk today about something that has been intriguing to me, and that is that many times I've been out talking to people in the industry, and we talk about DGA, and we love to talk about DGA at Transformer Technology, because to me, it is probably one of the most important tools that you can use if you're looking at the condition of a transformer as the transformer is operating. It is, I'm passionate about NICM, which is non-invasive condition monitoring that you can get. But I want to talk specifically about something that is a phenomenon happening, and I would call it end-of-life monitoring. Because a lot of people think, well, it's the end of life, I'm just going to replace it. And they begin doing their end-of-life capital planning to replace it. But we've just discovered from one of our partners who does market research in this area that the global lead time for power transformers, and that would go anywhere from a distribution transformer, large distribution, all the way up to a GSU, has gone from about 2 years and 2 months to 3.5 years, Senja, the lead time.
Wow, it's almost like double what it used to be.
Yes. And so people that think end of life is, well, I'm not going to do anything. And that's what we're going to talk today. We're going to talk about today is the fact that end of life is now critically important. So the first question that I've got, given that's the first question, obviously, that I've got, is when you have such long lead times, make a case for why it would be important to continue to monitor end of life power transformers in the utility industry.
So obviously it depends on a lot on policies of utilities, how they replace. Is it based on age only, or is it based on condition? I guess it's more and more coming that the decisions are based on the condition of the transformers rather than age only, because it's just a huge capital cost for having or replacing big power transformers. So at the end of life phase, the probability of getting faults and failures is increasing. And the longer you go, the longer you push the time for replacement, the more likely it is that there become issues. And like you said, DGA is the way to see those evolving or developing issues inside the transformer.
The bathtub curve for transformers, I mean, it's in the IEEE bathtubs. We've looked at it a long time. As a reliability expert, I love the bathtub curve. So it's got that, early stage startup. You buy it, you put it in, and everybody says, oh, put a monitor on that, and you keep it going. But we are well beyond life cycle planned that for transformers. So that end of life stage is what we're talking about here. And it has been extended. People are taking better care of transformers. But as you said, if it's just age, you're going to probably make bad decisions. If it is condition, you will make much better decisions about capital planning. There is a group out of Southern Cal Edison that did some research, and they did machine learning on the difference between replacing distribution transformers based on age and based on condition. And they didn't do condition being gas monitors. If they'd had that, that would have been like the gold standard of what they could have had. They did it based basically on the 7 conditions around a substation. But when they took condition into account, they saved $21 million when they back tested it. That was 2017. They back tested it again in 2018, and it went up to 40-something million dollars. And now they are actually applying that philosophy, that machine learning. It's not AI yet, but it is that part of AI that says if you know the condition then you can make much better decisions. And given the lead times we're talking about, that could be even now in the hundreds of millions of dollars for utilities. So it is proving the point that you're making, but there's some specific other things that matter here. So you've got a transformer, it's an older transformer, and you have a known fault. You already know it's got a fault. Why would you put a monitor on that transformer?
Because that fault you have there may develop further and more serious. And I think that's one of the really the biggest benefits on online monitoring at the end of life phase is that you have the fault there already, and it's possible and even many times likely that that fault will develop, and usually it develops worse. So that by having online or real-time DGA monitoring there, you can see if the gassing is accelerating, and if it's accelerating, it means that the fault is developing into something further and more serious, and that gives a time to react. Even though the lead times are so long, of course you don't have the replacement for the next morning, but at least you are able to take that transformer off service before something really severe or catastrophic happens.
Yeah, and the costs of a catastrophic are significantly higher. Number one, to get a crew in to replace it. We're going to talk about safety in a minute, but this is another interesting OSHA, the Occupational Safety Hazard Association. It's the government agency that tracks injuries and workplace injuries, things like that. And they have now got the power to fine and the power to prosecute. So they can take civil penalties and even criminal penalties if a company is not doing a good job or did not prevent injury. You are 10 times more likely to die from a catastrophic failure of a piece of equipment in the electrical world than you are in the mechanical world. Times more likely to be injured. That ought to scare us into thinking, look, we cannot let this grow to a catastrophic failure. We've got to do something. And as much as it's going to be hard to do planned outages and planned failures, that's what we got to be able to do. But talk a little bit about your perception of why the monitors do give us an extra measure of safety in the whole process, given what I just said about injuries and fatalities.
I've discussed about this topic with a couple of bigger utilities here in Europe, and those have internal policy that if they call them suspicious transformers that are on the end of life phase and are showing a gassing tendency. So instead of going and having more frequent oil samples, they have actually fenced that transformer off for people to get access to close to it, and they have online monitoring instead to show if the faults are developing. So that is the one safety measure for personnel. No need to go close by a suspicious transformer.
It's right. If you can read the chart from a distance, you're a lot better than having to walk up to it. Yeah, that's true. That's another safety principle is the non-invasive condition monitoring.
Exactly.
So part of the idea, and this came up in a presentation I think that you made that I listened to or watched, or read, but it was talking about when you use monitoring, it allows you to do end of life or do whatever you're doing in a controlled manner. What does that mean in a controlled manner?
I mean that with controlled manner that I have again a couple of cases recently where the utility had made already plans to replace. They had plans that it's this and this many months from now on that the replacement will take place. and obviously they had made the decision and ordered new replacement transformer there. But meanwhile, when they were waiting for the new one, they had the online monitoring to be sure that they can use the transformer to the end just before the replacement. But actually, both of those cases, I'm talking about the online monitoring showed that they couldn't wait that long. The gassing was increasing, and towards the end accelerated really the gassing, and they just had to trip off. And that meant that they could plan transferring that load to their other transformers and do everything in a controlled manner so that there was no disruption in the actual operations.
That, it's interesting. And I know that in Europe and in the United States, so many of the utilities now have created relay systems that allow that load transfer. That in the US, the utilities get fined if they have outages that last. They measure the outages by milliseconds, right? Yes. And so they get fined if that, because you don't know. So it's great cases, 3.5 years lead time. You can control this safety measures. There is no reason for a utility not to put a DGA monitor on an older transformer, just think it's going to be replaced. Any other cases for why they ought to do it? Because that's the case we're making today.
Yeah, I think those. Well, concerning the end of life, I think those are the ones that has occurred to me, and where I have the most experience are those transformers that are already having the gassing pattern, and one case was so that it had for years a thermal issue. It was creating some or producing some gases, and they followed it, and they added cooling there and so on. But again, towards the end, it was clearly developing, and by having the online monitor, they could react on that early enough, had the alarms in their systems, and so they were, of course, some extra work because they had to replace that transformer earlier than they initially anticipated, but everything went in a controlled manner so that the electricity production was not interrupted at all. So I think how I see it is the end of life phase is most crucial for transformers that has gassing issue already, and they obviously know that based on their manual DGA samples.
So last time we spoke, we made a case for putting DGA monitors at the beginning of life on newer transformers,
yep,
on transformers in service, and now we've made a case for putting monitors on transformers that are at end of life. Well, you've made a great case for that. Thank you so much for joining us today.
Thank you,
Senja. It's been great.
My pleasure. Thank you.